Good afternoon to everybody who is joining the session. I want to present you now our results of a rapid forest classification on the basis of high-resolution satellite data with Definiance Enterprise Image Intelligence software. But first, let me introduce to you the GAF company. GAF offers a variety of services. We do data distribution, which means we sell Earth observation data, digital elevation data, and also land use data. We also do data processing, which means image processing, digital cartography, and 3D reality. Further on, we provide image information systems, which means we do software development and distribution, as well as GIS and database design and implementation. And finally, we offer also management consulting. This means training and knowledge transfer, administrative capacity building, as well as project definition and supervision. Now, why do we use the Definiance Enterprise Image Intelligence software, especially the developer and the architect? So the first point is that the software is able to handle information extraction from high-resolution satellite data. Then we do appreciate the automation of classification processes, which is possible with the software. An easy transfer of rule sets to different data sets is possible using variables in the Definiance developer. Then the Definiance architect offers convenient possibilities for manual editing and so for automation of the production. This is for us very important because we do operational image processing projects and we need always production lines. And finally, we appreciate the easy integration of additional input layers in the classification process. So here you see the Definiance clients we actually have here at GAF. We have one Definiance developer and one Definiance architect. With the Definiance developer, we do the design of the ruleware. Now in this example, we are doing a forest classification. And with the Definiance architect, we do the performance of the ruleware and the execution, and then we are doing the post-processing manually. And the result is then a forest layer. Now I want to show you how we design the ruleware in the Definiance developer for a forest classification. And first I want to say some words to the project for which we did this forest classification. The project is named eCognition. It is a national joint project and 11 remote sensing companies are working on this project. We are doing, in the frame of the project, geoinformation services. We do an update and we produce land cover data of Germany. The basis are high-resolution satellite data, for example, spot or iconus data, and rapid eye and Terracer X data we want to use on a later stage of the project. The nomenclature comprises of 32 land cover classes. These are derived from the Korean land cover nomenclature and they are compatible to this nomenclature. Now the task of GAF within the eCognition project is to do the forest classification. We have to separate 4 forest classes. This is coniferous forest, deciduous forest, mixed forest, and currently unstocked areas. The minimum mapping unit will be 1 hectare and the minimum width of an object 25 meters and the accuracy 85%. Here you see our processing chain we developed for the classification of forests. We have 4 steps. The first step is a forest non-forest classification. On the basis of this forest map we do the distinction of the forest classes. Then we have filter operations to reach the minimum mapping unit and finally we do quality checks. Now I want to give you a deeper insight in the single steps. The first step was the forest non-forest classification. Here the challenge was to find a very solid, a rule for a very solid forest non-forest classification. The solution we found was to base the classification on textural and spectral characteristics of the forest. These characteristics we defined using variables which then can be adjusted later in the architect solution. And to maintain transferability, we preferred ratios to absolute pixel values when spectral criteria are considered. The second step, the distinction of the forest classes. Here was the challenge to find statistics which describe forest classes and which also take into account the variations due to different image conditions and variations across the area. The solution we found here was to compute statistical values of existing forest objects, and from these statistics we defined different forest classes. The parameters we found to differentiate the classes we defined variables for, and this was the basis then for the forest class distinction. Then the filter operation. Here we needed an automatic process, and here Definiens provides some rules to an automatic remove of all objects smaller than the minimum mapping unit. And for the final quality assessment check, here was always the challenge to ensure a correct implementation of the mapping rules, and here the Definiens software also provides rules to check the object sizes and the consistency of the results. So to summarize, what had been the advantages of the Definiens software for our project. So we had been able to classify high-resolution satellite data using textual information. Then we could utilize also topologic aspects for the classification. For example, we could detect shadows. Then further on, when exporting the classification results in vector format, the thematic attributes could be provided for further use in GIS operations. Another advantage of the software was that several image subsets could be handled in one project. You see on the right side that our project area was covered by 2 images, and it was possible to handle both images in one project. And afterward, the results could be merged and exported easily as one layer. And then the last point is that the use of variables and parameters enables a relatively easy transfer to different types of reference data.